how are you all? I hope you all are doing fine. So as you all know, the JEE Mains examination exam is very soon. Alright, so the dates for the first attempt of JEE Mains 2024 is already scheduled. Alright, so every person who is preparing for this particular examination must be in a kind of a tension kind of a situation. Alright, but you need not worry, because with a proper strategy of revision as well as technique of paper attention, you can definitely ace the particular examination. So I wasn't getting enough much time for preparing lectures on this particular channel, but from now onwards I'm on my winter vacation from my college, so I will be posting a lot of videos regarding revision techniques, the exam preparation techniques, as well as many tips and tips how to solve the paper in a kind of an tension kind of a situation. All right, so as you all know that I was continuing with the binomial theorem, so this will be a lecture 8, which is a continuation of the binomial theorem playlist. Alright, so if you're someone who is transiting from class 11 to class 12 and you haven't started or completed the binomial theorem till now, then it is a high or a good chance to finish this particular chapter. Go to the playlist of this particular video description and you will definitely find the playlist on binomial theorem. Also, you can check out the different playlists on my particular channel. Alright, so if you're someone who is new to this particular channel, and you please consider subscribing to it. Alright, and from now onwards, what I was planning is basically to start, because the JEE Mains examination are very near, so I was thinking to start the one shot on each and important topics of mathematics, only keeping in prime focus that is of the JEE Mains examination. Alright, so in that particular one shot playlist, I will be covering all the concepts, all the important formulas, as well as the important questions, and I will be taking up top 10 or top 15 important JEE Mains previous year question. Alright, so if you are new to this particular platform, then definitely subscribe to my channel and stay tuned. Alright, so let us start with these important 10 questions on JEE Mains previous year problems of binomial theorem. Alright, so the very first problem is on your screen. Alright, so what I will recommend all of you to just pause the particular video in this particular moment and just give a try. Okay, so you must be a student of class 12, then you must have already covered the binomial theorem and you must be revising the binomial theorem, then you can definitely give it a try. Or if you are a student who has started, who have completed all the lectures till lecture number 7 of binomial theorem and basically are looking for practice, then you can also definitely pause the video and try out this particular problem. So I hope you have paused the video and tried this particular problem. Alright, so let us read this particular problem. This particular problem says that there is a number. So let me write the number as, so the number, let the number be n. So the number is given as 22 raised to the power 2022 plus 2022 whole raised to the power 22. So it is saying that when this particular number is divided by 3, the number is basically of the format 3k plus alpha. That is the remainder of this particular number when divided by 3 is alpha. And when this particular number is divided by 7, it basically gives you a number which is of 7 mu plus beta. That means the remainder is 7. Alright. So you must have known this particular format when I was already teaching about the concept of remainder theorem on binomial topic. Okay, so you know how to tackle these kinds of question. So very first thing, when you basically need to find the divisibility by number 3, what you need to check for. So you can see from the number 22 that 22 can be written as 21 plus 1. Okay, 21 plus 1. Now why I am writing this number as 21 plus 1? Because you know that 21 is a divisible by 3. Okay, so this particular number can be written as 21 plus 1 whole raised to the 2022 plus, and if you look at this particular number 2022, so if you check this particular number, if you check the sum of the digits, it is divisible by 3. That means this particular number is divisible by 3. Alright, so before solving this portion, I wanted to take a note, because the divisibility criteria rules you must keep in mind. Okay, I hope you have done this particular divisibility criteria in your junior classes when you were in class 6 or 7, or maybe in 5th or 4th standard. Alright, so if you have done that, it's well and good. If not, then you can like Google it on your own self, okay, to find out like divisibility conditions by the number like 2, 3, 5. Alright, so you can check out on this, or if you're not, then well and good. So let us start. I'm not going to repeat those particular divisibility condition. Alright, so maybe if you are not unaware of the divisibility condition, then definitely comment below in the comment box. Maybe I will take a short video on this particular topic. Alright, so let us start with that. And if you look at 2022, it is divisible by 3. That means if you divide this particular number whole raised to the 22, it will be divisible by 3. So the only problem will be with this particular number when we will divide by 3. Alright, so if you binomially expand this particular number, this particular will be 2020 C0 21 whole raised to the power 2020 plus 2022 sorry 2022 C1 21 raised to the power 2021, okay, and 1 raised to the power 1. Alright, and so on up to the last term. The last term will be 2022 C 2022 1 raised to the power 2022. Alright, so if you look at this particular term, except the first term, you will find that all these particular terms are divisible by 3, because this particular all the terms has 21 as the common factor. Okay, 21 as a common factor. So if you can write this particular number as 3 times of some constant plus of 1, because this particular quantity is 1, this particular quantity is equal to 1. Okay, if you evaluate this particular is equal to 1. So from here you can see the number when divided by 3 yields the result like 3 mu plus 1, which is of the format 3k plus alpha. That means from here you can say that the number when divided by 3, this particular number yields the remainder which is equal to 1. So you can check that alpha value is equal to 1. Now solving for the next particular condition, where what happens when the number is divided by 7. Okay, so if you look for 22, so you can see 21 is basically divisible by 7. So that means you can again write 22 as 21 plus 1 whole raised to the power 2022. And if you look at 2022, so if you find the divisibility of 2022, so if you divide by 7, so what the value is? So if you divide by 7, it is 214 and 6 remainder. So if you then 62, then it's 8 times and it is 56. So it will become 6 and again 2. So it will be 288 and the remainder will be, so this will be 56 and the remainder will be 6. So you can also write this particular 2022 as some multiple of 7 minus 1. Okay, so instead of writing 7 into 288, you can also write this particular 7 into 289. Okay, 7 into 289 minus 1. I hope this particular thing is clear. So that means you can definitely express this particular number as, okay, so this implies that you can also write this particular number. That means instead of 2022, the number 2023, the number 2023 is basically divisible by 3. Is 7, sorry. Is divisible by 7. All right. So this particular thing implies that the 7 into 289 minus 1 is basically the number which is 2022, and this is raised to the power 22. Okay, so you can also write this particular number as 7 multiple or some multiple of 7 plus 1 whole raised to the power 2022 plus some 7 multiple. Okay, so let me write this as k1 and this as k2. So this is also k7 k2 minus 1 whole raised to the power 22. Now, if you observe, if you want to binomially expand this particular number, then this will become 7 multiple plus the last term. Okay, because all the multiples, because if you see at this particular, if you binomially expand this first term, the multiples regarding this, whenever the terms containing 7k one term will always be divisible by 7. So instead of writing this particular, I am writing in form like 7 multiple some k plus, and if you look at the last term will become 2022 C 2022 C 2022 and 1 raised to the power 22. Sorry, if I did any mistake. Oh, no, it will be 2022. Okay, and plus if you look at these particular numbers, then again this the first term containing all the numbers will be divisible by 7. That means this will also become some 7 multiples. Okay, some 7 multiple. And if you look at the last term will become, so if you look at the last term will become 22c 22 minus 1 raised to the power 22. But since minus negative raised to the power even number is of course a positive number, and that means this particular will yield a number which is 7 mu or 7 mu dash, where mu dash is a constant. Okay, where 7 mu dash is a constant integer, it's an integer. Okay, better to write an integer. Okay, where mu is an integer. Okay, so that means this particular number is divisible. And plus, so if you look at this last term, this is plus 1 and this is plus 1, so this will yield a remainder which is equal to 2. So that means when the number 7 is number n is divided by 7, this particular gives a number which is of fashion 7 mu times plus plus 2. That means the remainder from this particular scenario is equal to 2. That means when the number n is divided by 7, the remainder yields is basically 2. And from here, you are basically asked in the particular problem to calculate the value of alpha square plus beta square. So you know that alpha square is 1 and beta square is 4. So this will yield you the result that is equal to 5. So from here, the right answer to this particular problem, by now if you have done it correctly, then you must have known that is option number D. So the option number D is the right answer to this particular problem. So how many of you have been able to solve this particular problem on yourself and also match the particular answer as well? All right, so do mention that particular thing in the comment section. All right, so how much you are able to access yourself also matters in this particular times of CBT examination. All right, so with this, let us move to the second problem. All right, now this particular second problem is a very important problem. Okay, so you can find this particular problem many times repeating in the JEE Mains paper. Okay, so many times this particular type of problem was repeated in your previous year, as well as this type of problem was also asked in a JEE Advanced examination of 2014. So you can check out the 2014 JEE Advanced paper and try find the question on binomial theorem, or maybe 2013 if I'm not wrong. Okay, 13 or 14, somewhere around that only. All right, so if you find that particular this particular type of question was already asked. All right, so this makes this particular type of problem very important. All right, so if you look at this particular problem, the problem says that the coefficient of the three consecutive terms in the expansion of binomial expansion of 1 plus x raised to the power n are in the ratio 1 is to 5 is to 20. Then you are basically asked to find the coefficient of the fourth term. All right, so from this particular information of binomial expansion, so the binomial expansion is 1 plus x raised to the power n. All right, so the binomial expansion is 1 plus x raised to the power n. So from this particular binomial expansion, if you have to consider the three consecutive terms, let me consider the three consecutive terms as the rth term, the r plus 1th term, and the r plus 2th term are the three consecutive terms. Okay, all right, so they are the three consecutive terms. So if you look from here, these are the three consecutive terms. Let us assume that. So from here, if you look at the three consecutive terms, so first it is said in the problem that the ratio of the r plus 1th term with the rth term is basically in the ratio 5 is to 1. And similarly, if you look at the r plus 2th term with the r plus 1th term, they are in the ratio 20 by 5. That means of 4 by 1. Okay, so simple ratio is 4 is to 1. All right. So from the concepts or the knowledge we have already acquired in this particular chapter, that is our important formula, that is NCR divided by NCR minus 1, and this particular is a very important result that you must remember, and this result is n minus r plus 1 divided by r. So if you are knowing this particular formula or the important formula, then you basically are able to solve this particular problem on yourself only. So if you are looking for the r plus 1 term, so what is the r plus 1 term? You will say that the r plus 1 term is nc r min sorry, r plus 1 term, so this will be ncr. Okay, 1 raised to the power n minus r and x raised to the power r. So you are only looking for the term, that means that x raised to the power r doesn't matter because the question is asking you for the coefficient. So that means the coefficient will be ncr divided by, for the term of rth term, it will be nc r minus 1, and this giving in the ratio 1 is to 5. All right, sorry, 5 is to 1. So from here you can evaluate and get to one formula, that is n plus r plus 1 divided by r is equal to 5. So from here, if you rearrange this particular number, that's n minus r plus 1 is equal to 5r. So from here n is equal to 6r. So n is equal to 6r minus 1. So from here you will get the value of n as 6r plus minus 1. All right, so this is the first equation. Let me label this as first equation. And now the second case, if you look at the tr plus 2, okay, divided by tr plus 1, they are in the ratio 20 by 5, which is equal to 4 by 1. So from here you will find that this is nc r plus 1 divided by nc r. Okay, so this is equal to 4, and from here if you simplify, this will become n, and in place of r you have to put r plus 1, so this will be n minus r plus 1 plus 1. All right, n minus r plus 1 plus 1 divided by, in place of r you have to put r plus 1, and this is equal to 4. So from here if you cancel out the terms, this is n minus r is equal to 4r plus 4. So from here the value of n you will get it as 5r plus 4. So let me label this as equation number 2. So on solving equation 1 and 2, okay, solving equation 1 and 2, we get so from equation 1 it was 6r minus 1 equal to n, and from equation 2 n is equal to 5r plus 4. So from here, if you simplify, this will become r is equal to 5. So from here, you will get the value of r as equal to 5. Okay. So if r equal to 5, that means the value of n will be equal to 25 plus 4, that is 29. So from the value of n r is equal to 5, we'll get the value of n is equal to 29. So if you get the value of n is 29, and the question is asking you for the coefficient of the fourth term. So if you know the fourth term, the fourth term will be like P4 is equal to the coefficient of the fourth term will be equal to 29C3. Okay, so the fourth term equation will be 29C3. The coefficient of the fourth term will be 29C3. So from here, if you evaluate by using the formula, or you know this how to evaluate this, because I have already taught you the short trick. So you can see that this particular 2 times and this is 9 times, and these 2 will cancel out with 14. So this is the value is 14 into 9 into 29. So you have to basically calculate it. So let me use some short tricks. Okay, so if you evaluate the last value, so you can see that the last term will be basically 4. So from here, the only option which has the last term as 4 is basically option number A. So you can definitely calculate it on yourself and definitely get to the particular answer also. Okay, so if you can calculate, that is 29 into 14 into 9, and that value comes out as, okay, also comes out as, so you can perform it and okay on yourself. So the value is 3654. Okay, so you can also calculate it on your own also and check. All right, and the value is 3654. Okay, I have done that in my calculator. Alright, so from here, the right answer to this particular problem is option number A. I hope this particular thing is clear. Alright, so with this, let us move further and solve the third problem of this today's important JEE Mains previous year questions. And third problem is again an important, very important type of question that keeps on repeating in different shifts also. Okay, so you can find these types of problems many times in asked in a binomial theorem chapter from for your JEE Mains examination point of view. Alright, so if you read this particular problem, it is saying for the if the ratio of the fifth term from the beginning to the fifth term from the end is basically in the ratio root 6 is to 1 of this particular binomial expansion, then what is the third term from the beginning? So I've already taught you that whenever you are considering for terms from end as well as from terms from beginning, for the terms from end, you basically need to replace the binomial terms. Okay, so if you are asked for the first term of the n terms of the binomial expansion a plus b raised to the power n, so this particular thing also similar to the that particular term from the beginning of b plus a whole raised to the power n. So this particular concept was already known to all of you if you have followed my lectures. All right, so if you have followed my lectures, then you must be aware of this particular problem, this particular kind of problem. All right, so for the fifth term from the beginning, so let me write the binomial expansion. The binomial expansion is 2 raised to the power 1 by 4 and 1 by 3 raised to the power 1 by 4, okay, whole raised to the power n. So it is asking you for the fifth term. Okay, so it is asking you for the fifth term from the beginning. So the fifth term from the beginning is equal to NC. In place of R, you have to put 4. So NC4, 2 raised to the power 1 by 4 whole raised to the power n minus 4 and 1 by 3 whole raised to the power 1 by 4 into 4. Alright. So from here you get the fifth term from the beginning as NC4 and 2 raised to the power n minus 4 by 4 into and 3 raised to the power 1 by 4 into 4, this cancel out, so this will become only 3. So this is the fifth term from the beginning. Now for the fifth term from the end, we basically need to replace, we basically need to interchange. Okay, we basically need to interchange the terms. So if you interchange the terms of the binomial variates, then and raised to the power n. So for the fifth term, again this will be similar to the fifth term from the beginning of this particular binomial expansion. For this particular binomial expansion, the fifth term from the end is same as the fifth term from the beginning for this particular binomial expansion. So this is equal to T5 again, and this T5 will yield the result NC4 1 by 3 whole raised to the power 1 by 4 into n minus 4 into 2 to the power 1 by 4 into 4. Okay, so this 4 get cancelled, and the result you get is NC4 1 by 3 whole raised to the power n minus 4 by 4 into 2. Alright, so what is said in the question? So let me represent this t5 from the end as t5 2 and this t5 from the beginning as t5 1. Okay, so it is asked in the problem as the t5, okay, t5 1 divided by t5 2 is the ratio of root 6 by 1. Okay, so the ratio is given as root 6 by 1, and you can also write this root 6 as root 2 into root 3 by 1. Now why did I do so? Because of this particular complexity, because 2 and 3 are only involved in the problem. So if you divide this, the NC4 and NC4 from both the get cancel out, so the left out term is 2 raised to the power n minus 4 by 4 divided by 3 into. So if in dividing by this, it can also be written as into the reciprocal of it. The division is basically reciprocal of this particular number. Alright, so that is basically equal to, that is equal to, alright, so from here if you see, that is basically equal to 1 by divided by this particular or multiply with the reciprocal as this, and this will give you 1 by 3 raised to the power n minus 4 minus 4 into 2, okay, which is equal to root 2 into root 3. So again if you simplify this is 2 raised to the power n minus 4 by 4 minus 1. So if you divide this, then it will be minus 1, and similarly if you take 3 on the top, then it will be 3 raised to the power n minus 4 by 4 minus 1. If you divide this 3 with this particular 3, then this particular result is equal to root 2 into root 3. So from here if we check, the indices associated with 2 and the indices associated with 3 is basically equal to half. So the indices associated with 2 and 3 are basically half. Okay, so from here if you solve, that this will become n minus 8 by 4 is equal to half, and if you cancel out, this is equal to n is equal to 10. So from here if you get the value of n is equal to 10, so you can put also n in here and check the n is equal to 10. All right, so n is equal to 10. So with the value of n is equal to 10, you are only have to look for the third term from the beginning of this particular binomial expansion. The third term from the beginning, that is will be 10c, 10c2, 10c2, 2 raised to the power, and that is 2 raised to the power 8 by 4 into 1 by 3 raised to the power 1 by 4 into 2, and this will yield the result, that is 10c4 is equal to 10 into 9 by 2 into 2 square, that is 4 divided by root 3 divided by root 3. So from here if you cancel, this is 45, 45 into 4. So you can also cancel this root 3. This can also be written as 3 into 3 root 3. Okay, 3 root 3, and this will become 20. This will become 20 root 20 into 3, that is 60, 60 root 3. The answer to this particular problem will become equal to 60 root 3 is equal to 60 root 3. So the answer is equal to 60 root 3. So with this, the right answer to this particular problem is option number B. Option number B is the right answer to this particular problem. I hope this particular simple problem was clear. Alright, so with this let us move to the fourth problem. Okay, and this is a very interesting problem that came in your JEE mains paper. Okay, so this type of problems actually comes up in a paper, and people definitely leave this particular problem. So if you are able to solve this particular type of problem, then you are always in a like a one step ahead or one in a forward zone. Alright, so this type of problem actually decides the rank. I hope so. The ranker students who are basically trying to improve their rank, then definitely focus on these types of tricky problems. Okay, so I will teach you how to solve this particular problem. If you had someone who has already done the sequence series, okay, then you might have understood the concept or the try to solve this particular problem. So this is a kind of problem which involves recurrence relation. Okay, recursive relations. Okay, so if you have someone who is very familiar to programming, then you must know that what is recursive function. So similar to this is also kind of a recursion, okay, which is involved in this particular problem. So if you look at the problem, the sum which is asked in the problem is basically sigma, where r is equal to 1 raised to 20. Okay, it is asking you for the sum of r squared plus 1 in multiplied with r factorial, multiplied with r factorial. So what will be the answer? Okay, now you have to evaluate the answer in terms of factorial only. Okay, so if you look at this particular summation, so let me look at the particular summation. Before looking at the particular summation, let me check what is the that is the general term. So if you look at the general term, this is r square plus 1. So if you look at the general term, okay, that is r square plus 1 into r factorial. So if you cross multiply, if you open this bracket, and you can write this as r square into r factorial plus r factorial, and you can write this r square into r factorial as r into r into r factorial, okay, plus r factorial, okay. So this particular thing also you can evaluate it as, so r you can keep it as r plus 1 minus 1 r factorial plus r factorial. Now why I am doing so? In order to generate r plus 1 factorial, r plus 2 factorial, because if I am able to calculate or create r plus 2, r plus 1 and r factorial, then definitely, and with the interchange or plus and minus sign, then definitely they will go on cancelling out each other when the summation is taken. When the summation is taken, they will go on cancelling each other. But that is the main funda of recursion relation. Alright, so from here you will get the general term as r into r plus 1 factorial. Okay, so this will as evaluate as r into r plus 1 factorial minus r into r factorial plus r factorial. Okay, now this r plus 1 factorial can also be going into r plus 2 minus of 2 into r plus 1 factorial. Okay, and minus, and this again can also be written as r plus 1 minus 1 into r factorial plus r factorial. So if you evaluate this, this will become, so this particular will become equal to r plus 2 factorial minus 2 r plus 1 factorial. Okay, so this will become 2 times of r plus 1 factorial, and this will become again, so this is minus of r plus 1 factorial. Okay, this is minus of r plus 1 factorial and plus of, so r factorial from here and r factorial here, this will become plus 2 times of r factorial. I hope this particular step was very clear. So from here if you club the terms as r plus 2 factorial minus r plus 1 factorial as the first bracket of this particular some general term plus 2 times of 2 times of r plus 1 factorial minus of r factorial. Now why did I do so? Because if you see in this particular problem, all the numbers which will come in this when summation is taken, they will go on cancelling out each other. So if you take the summation of the general term from r is equal to 1 to 20, so this particular will yield you the result. So if you put r as 1, so this is equal to 3 factorial minus 2 factorial, okay, plus I'm evaluating in the first bracket at first, okay, plus 4 factorial minus 3 factorial, and so on up to the last term will be 22 factorial minus 21 factorial. Okay, so if you look at this first bracket, this will be the first bracket, and similarly for the second bracket, this is 2 times of, so if you put the last term at first, this 21 factorial minus 20 factorial plus this will become again is equal to 20 factorial minus 19 factorial, and so on up to the last term will become will be plus of 2 factorial minus of 1 factorial. So if you evaluate this, if you look at this particular situation, that is 3 factorial get cancelled with this. All right. Similarly, 4 factorial will can cancel with this, and this 21 will get cancelled, because if you look at the cancelling fashion, so the first term get cancelled with the next term. The first term of the first bracket get cancelled with the last term of the second bracket. That means this 22 factorial will be left out, as well as this particular 2 factorial will be left out. Similarly, if you look at the cancellation fashion of this particular, this the last term of the first bracket get cancelled with the first term of the last bracket. That means this particular term will be left out, and this particular term will get cancelled. Okay, so from here the answer will be equal to 22 factorial minus 2 factorial plus 2 times of 2 times of 21 factorial 21 factorial minus 1 factorial. And if you know that 2 factorial is equal to 2 and 1 factorial is equal to 1, so this will definitely become minus of 3. All right, so the answer that will be left, sorry, this will be 2. Okay, so this will be 2, and if you are adding them, and this is negative, okay, so the last term will be an addition term. Okay, so this is 2 times of 2 1 factorial, this is equal to 2 only. So if you cancel this particular term, so this particular both the terms will get cancelled out. Okay, because if you put let me check for a sign error or not. So the result will be sum is equal to, so that means this will give you the result, that's 22 factorial plus 2 times of 21 factorial. This will become equal to 22 factorial minus 2 times of yeah, that's the mistake, I guess. Okay, so this will be minus of 2 times of 21 factorial. Okay, so there is a sign error. Okay, yeah, I got the sign error. This is equal to minus 2 times of, okay, this is minus 2 times of, because if you take this is minus 2 is common, so if you take minus 2 common, then this will become minus only. Okay, so yeah, that was a sign mistake from my side. Okay, I'm sorry for it. So this will become minus and this will become plus. So this will become minus, and that will make, so if you, this is become minus and this will become plus, and that will make 2 factorial, and 2 factorial get cancel, and the answer is 22 factorial minus 2 times of 21 factorial. Okay, so the answer is 22 factorial minus 2 times of 21 factorial. So with this, correct answer to this particular problem is option number B. So I hope this particular problem is clear. It's very simple but a tricky problem. Okay, so you are basically need to generate a recursion relation whenever this types of summation is involved. Okay, so I hope this particular problem will create a good impact on your paper. Okay, so if you are someone who is preparing for in a good level of preparation and looking for tricky problem, this is one of the tricky problems that came up in a JEE Mains paper. Okay, so with this, let us move to the fifth problem. So the fifth problem is again a very simple problem, as you can see from here. So if you look at this particular problem, so it is asking you, it is saying that the k be the sum of the coefficient of all odd powers of x in the expansion of 1 plus x raised to the power 99. So if you look at the expansion of 1 plus x to the power 99, so if you look at the sum of all the coefficient, so the sum of all the coefficient, okay, so I'm writing s for sum of all coefficient. So sum of all coefficient is equal to 2 raised to the power 99, but only for the sum of the odd coefficient. That means the sum of the odd powers of x, that will become is equal to 99c1, and the coefficient of all odd powers of x will become 99c3, and similarly up to 99c99. Okay, so this particular summation and the summation of which is left in the series is equal to 2 to the power 99. So you know that this particular summation and this particular summation are equal. Okay, so this will yield to the result that the sum of all the odd coefficient of all the odd powers of x, that is I'm looking for s1, is equal to 2 to the power 99. Okay, 2 to the power 99 divided by 2. Okay, and this will yield to the result that is 2 to the power 98, because this is 2 times the summation and that is equal to 2 to the power 98. Okay, so the first summation, that is the value of k, so the k you are looking for this particular problem is equal to 2 to the power 98, 2 to the power 98. Okay, so the value of k is equal to 2 to the power 98, and also it is saying that alpha is the middle term, okay, middle term of the binomial expansion 2 plus 1 by root 2 whole raised to the power 200. So you know that the total number of terms in this particular expansion is equal to total terms, okay, total terms equal to 2001 201, sorry. So that means the middle term will be equal to, because n is an even, so the middle term is equal to n2 divided by the 2 plus 1 term. Okay, so the middle term is equal to n by 2 plus 1 term. This will yield you the result that alpha is equal to, so if you know that n by 2 plus 1, that is equal to 101 term, so this will become 200c 100, 200c 100, and 2 raised to the power 100, 2 raised to the power 100. Okay, and 1 by root 2 raised to the power 100. Okay, so from here you will get the result as 200c 100, 2 to the power 100 minus 2 to the power 50. So that means 100 minus 50, that will become is equal to 200 c 100 2 to the power 50. Okay, and what is asked in the question? It is asked in the problem that is 200 c 100 2 to the power 98 divided by 200 c 100 2 to the power 50 is equal to 2 to the power l, 2 to the power l, okay, 2 to the power l m by n, and it is not 200c 100, it is 200c 99, this is 200c 99. Okay, which is given as this particular format. So if you look at this and you evaluate this, this is again of similar form, that is ncr divided by ncr plus 1. So this will become, so this n is equal to 200, r is equal to 100 plus 1 divided by r. Okay, and for the 2 raised to the power terms, that is equal to 2 raised to the power 48, which is equal to 2 to the power l into m by n. So if you evaluate this, this will become, so in place of l is equal to 48. Okay, l is equal to 48, and if you evaluate this 100 by 100 plus 1. Okay, so 100 by 100 plus 1, so the m value is equal to 100 and n value is equal to 101. So from here the answer is asked for the ordered pair of l comma n, the ordered pair of l comma n. So this is 48 comma 101, so this is equal to 48 comma 101. but it is also said that m and n are odd numbers. But it is also said that m and n are odd numbers. Okay, so this particular is also given out as in the fashion m and n are odd numbers. All right, so in order to create odd numbers, because the question is looking for odd numbers, okay, because it is saying in the question that m and n are odd numbers. All right, in this particular problem the n is coming out as odd number, but the m is not coming out as odd number. Okay, so this creates a kind of a confusion kind of situation. Okay, so you can also evaluate this particular situation, okay, by taking out from here. If you take like with like 2, if you manage to find it with 15 to 2, and that can also be 25 into 2 square, and this will also yield you 25. So but simultaneously, if you have to take 4 out from here also, it is 101. So this will give you a problem. This will become 50, and 50, at least this will not be divisible by 2 only. Okay, so let me check for it. Okay, so because m and n are odd numbers, so what I was trying to do, instead of taking 100, is I was writing as 25 into 4. And if I do so 25 into 4, and if I do so 25 into 4, that will make m as equal to 25, which is an odd number, and n is also an odd number. But in that particular scenario, yeah, I have to take like 4 as 2 square, and this will make, this is 2 to the power 48 plus 2. So instead of l is equal to 48, this will make, okay, instead of l is equal to 48, instead of l is equal to 48, this will make l is equal to 50. And from here the order pair of l comma n is 50 comma 101. So 50 comma 101 is the right answer to this particular problem, which is option number A. So as you can see, this is option number A. I hope this particular problem was clear. Okay, very pretty simple question. So let us move forward to the sixth question. And the sixth question says as, okay, the sixth question is very simple problem. It is saying for two positive real numbers a and b such that 1 by a square plus 1 by b cube is equal to 4. So this particular relation is given, and whenever you are were asked to find out minimum value, then basically get to understand that there is some GM, AM, GM, HM mean is involved. Okay, AM, GM inequality is involved. So if you look at that expansion, so it is asking you for the value of the constant term in the expansion of this particular binomial. So the binomial expansion is given as a x to the power 1 by 8 plus b x to the power 1 by 12 whole raised to the power 10. So if you look for the general term will look like 10 CR ax to the power 1 by 8 whole to the power 10 minus r, and bx to the power 1 by 12 whole raised to the power r. So from here, if you evaluate this, this will equal 10 CR, okay, a to the power 10 minus r, okay, and b to the power r. And for x, if you evaluate, this will become x to the power 10 minus r divided by 8, okay, minus r by 12, okay, this is the power of x. So in order to get the constant term, okay, so for constant term, the power of x, whatever is present in the power of x, that means the power of x should be equal to 0. Okay, so whatever the x term should be independent of this x term, because for the constant term the x must not be present. That will make 10 minus r by 8 minus r by 12 equal to 0. So from here, if you solve for this particular equation, that is 10 minus r is equal to 10 minus r by 8 is equal to 12, r by 12. So from here, if you cancel, this is 2 and this is 3. So this is 30 minus 3r is equal to 2r. So from here, r is equal to 6. So from here, r is equal to 6. So you got the value of r is equal to 6. Okay, so you got the value of r is equal to 6. That means the general term will look like, okay, such that the minimum value of the constant term. So that means the constant term is equal to, so the constant term is equal to, so that is 10c r, and r will be 6, so 10c 6, a to the power 10 minus r, that is a to the power 4, and b to the power r, that is 6. So this will be the constant term. So you have to look for the minimum value of the constant term. So if you evaluate this 10c6 value, so if you evaluate the value of 10c6, so 10c6 is equal to 10c4, and 10c4 is equal to 10 into 9 into 8 into 7 divided by 24, that is 4 factorial. So this will cancel out as 3, and this is 3. So this will be equal to 210. Okay, so the 10c4 value is 210. So the constant term is equal to 210 times of a raised to the power 4, b raised to the power 6. Okay, now if we use by gm greater than or equal to hm inequality, equality only exists when the numbers are equal. Okay, equal inequality. Okay, so by this particular inequality, gm greater than hm inequality, now why do I basically choose to use this particular inequality? Because the number given out in this particular scenario is basically the 1 by a cube, sorry, a square, 1 by a square plus 1 by b cube was given out. 1 by a square plus 1 by b cube, the value of 1 by this was given out. So this particular resembles to the kind of situation when we basically look for the hm, that is a harmonic mean. So this particular, so if I take the two numbers for a square and b cube, for this particular a square and b cube, this can be written as a square b cube square root is greater than, so for two numbers it is equal to 1 by 1 plus a square plus 1 by b cube. Okay, this is greater than this particular number, and from here if you evaluate this, this will become a square b cube whole square root is greater than, so if you evaluate this is 1 by 4, so this will be equal to 1 by 4. So from here if you take the square on both the side, this will be greater than 1 by 16, but you are asked to find the a की power 4 and b की power 6. So if you take again a square, you have to take again a square, and this will be greater than 16, 1 by 16 ka whole square, that is 1 by 256, that is 1 2 to the power 8. Okay, so from here if you find the minimum value, so the minimum value is equal to 210 into 1 by 16 into 1 by 16. Okay, so if you cancel out with 2, this will be 8, and this, if you cancel by 2, this will equal to 105. Okay, so 105, and this is 16, so 105 by, so if you look at the answers, so it will be 105, and there is 16 in denominator, so maybe if I haven't done any mistake. Okay, so there is a mistake from my side. This is 2 greater than 2 times of. Okay, so there is a mistake from my side, because if you look at the harmonic mean formula, this is r by 1 plus a1 plus 1 by a2 and so on up to 1 by 1 plus ar. So from here this will become actually 2 by 4, this is equal to 1 by 2, so this will be greater than 1 by 4. Okay, and this will be greater than 16. Okay, this will be greater than 16, so this will evaluate as 16, so there will be only 16 left, so that means this is 105 divided by 8, so the answer will be 105 divided by 8. Okay, so the answer will be 105 divided by 8, that is option number C. Okay, so there was a small error from my end. Okay, I'm very sorry for that. Okay, so this will be greater than 105 by 8, that means the minimum value of the constant term of this particular expansion is equal to 105 by 8. So I hope this particular problem is clear. Now let us move to the seventh problem. Okay, now this is again a very simple problem. So if you look at this particular problem, okay, so this problem is asking for the summation of 31 ck and 31 ck minus 1. So this is the first summation. So I'm assuming this particular summation as some number lambda, and the second summation that is asked in the problem, so where the value of k goes from 1 to 31. Okay, and here the k value go from 1 to 30, is 30 ck into 30 ck minus 1, and this value is equal to, let me label as mu, and it is said in the problem, that lambda minus mu is equal to alpha into 60 factorial divided by 30 factorial divided by 31 factorial divided by 31 factorial. Okay, so if you look at the first summation, the summation of the first problem is given out as 31c1 and 31c0 plus 31 C2, 31 C1, and so on up to 31 C31 into 31 C30. Okay, so this is 31 C30. Okay, now we know a very important relation, that is NCR is equal to NC n minus R. Okay, so by using this particular relation, I can write as 30 C0 as as 30, sorry, 30 C1, I can also write it as 31 C30, and 31 C0 plus 31 C, this can be written as 29 31 C1, and so on up to 31 C, 31 C0, 31 C30. Okay, now what is the advantage of doing this particular? Because if we are doing this particular, we find that the sum of the lower indices of binomial coefficient is constant in all the cases. The sum of the lower indices of binomial coefficient is constant, and I have already taught you, when the sum of the lower indices of the binomial coefficient is constant, keeping the upper part is also same for all the terms, then the sum of the product of binomial coefficient containing the binomial terms where the lower indices are, the sum of the lower indices are constant, then the value is directly equal to sum the upper part, that is 62C, and sum the lower part, that is equal to 62C30, 62C30. Okay, so the answer of lambda is equal to 62C30. And similar fashion, if you evaluate mu, if you evaluate mu, so this will become 30C1, okay, 30C1, 30C0, and plus 30C2 and 30C1, okay, and so on up to 30C30 into 30C29. Okay, so with this, if I again use that particular formula, that NCR is equal to NC R minus N minus R. So from here I can write this as, that is 30C1 is 30C29, and this is can be written 30C0 plus 30C28, and this can be written 30C1, and so on up to 30C0 into 30C29. So again you see the sum of the lower binomial indices is basically constant and is equal to 29. So this will become equal to, 30C 30C 29. So the value of mu is equal to 60C 29. So 60C 29, and the value of lambda is 62C 30. So the problem that is asked is 62C 30 minus 60C 29 is equal to alpha times of 60 factorial is given divided by 30 factorial divided by 31 factorial. Okay, so if you evaluate this again, now for value of alpha you have to solve this particular, so I can write this 62C30. So for this I can also write this as, this particular terms I can establish this as 62, so I can write this 62 divided by 30 into 61 divided by 29. Okay, 62 divided by 29, 29, okay, into 60 C28 minus 60C 29. Okay, so this is the value of the summation. Okay, so now you can try to basically put the values like 60 factorial divided by 28 factorial into, and the remaining factorial, and if you evaluate this particular, okay, you have to basically go on solving this particular evaluation, okay, on yourself only. So if you evaluate this particular evaluation on yourself, and then find the value of 16 alpha, and then you have to find for the value of 16 alpha, and then you have to look for the value of 16 alpha. Okay, so if you do so, you'll get to the particular right answer. Okay, so my task was only to basically give you the idea like how to solve this particular problem. I hope you can definitely do this particular calculation on yourself. Okay, this particular calculation is very simple. Okay, how can you calculate this particular calculation? That basically depends on you, like how are you basically going to approach this particular calculation on yourself in an examination temperament. So what will be my suggestion to for this particular calculation? Okay, like try to take 60C28 and then establish it in form of 60 factorial. Firstly take 60 factorial common, and then take 28 factorial and 29 factorial is given over here, then multiply it with this particle will become this, make it the lower part will make it 30 factorial, and similarly this will be left out as 29 factorial, then cross multiply with 30 on up and down, and you will get as 30 factorial down, then take 30 factorial common. Now for 31 factorial you again take 31 as common, and then multiply it with 31 and get the 31 factorial also. Okay, so that's the way to solve this particular problem. Okay, now I won't be saying much to solve how to solve this particular problem, but that depends on your IQ, like how are you going to solve this particular problem to get to the value of alpha. So that depends on you. Okay, so with this, let us move to the next problem. Now, next problem is again a very simple and interesting problem. So if you are someone who has basically prepared sequential series, then you must know how to solve for the summation of GP. So if you look at this particular summation, this is nothing but a GP. So if you can see the second term, there is 2 to the power 2 to the power 2 and 3 to the power 9. That is the second term divided by 1 by 2 to the 2 into 3 to the power 10, and that this will basically give you the ratio of the geometric progression, and the ratio will become 3 by 2. So if you look at the ratio is basically 3 by 2. Okay, so the ratio is equal to 3 by 2. So this particular is a summation of a GP. So sum of a GP is basically formula is given by a into r raised to the power n minus 1 divided by r minus 1. So if you apply this particular formula, then this is 2 to the power 1 by 2 into 3 to the power 10 into r. The value of r is 3 by 2 whole raised to the power n. So what is the value of n? So if you can see, there is 2 that starts from 1 and goes up to 10. So that means the value of n is equal to 10. Okay, so that means there are 10 terms divided by 3 by 2 minus 1, which will basically yield you the result that is equal to half 1 by 2 into 10 to the power 3 to the power 10 into, so I'm writing from here, into 3 by 3 to the power 10 minus 2 to the power 10, okay, whole divided by 3 to the power 10, okay, whole divided by 3, sorry, 2 to the power 10 whole divided by 2 to the power 10, okay, whole divided 2 to the power 10 into 1 divided by 1 by 2, that means multiplied by 2. Okay, so this particular time is 1 by 2, and if you take this up, this will be into 2. Okay, so this particular result, the 2 and 2 get cancelled from here. Okay, 2 and 2 get cancelled, this particular 2 get cancelled with this particular 2, and the result which is left out is basically 3 raised to the power 10 minus 2 raised to the power 10 whole divided by 3 raised to the power 10 into 2 to the power 10. So this is the result, and this said that the value is equal to the sum of the value of GP is equal to k divided by 2 to the power 10 into 3 to the power 10. So from here the k value of k is equal to 2 to the power 3 to the power 10 minus 2 to the power 10, and the number that is k, the number k is equal to 3 to the power 10 minus 2 to the power 10, and this is said that if you divide it by 6, if it is divided by 6, what is the remainder? If it is divided by 6, what is the remainder? So if you are asked for divisible by 6, so when is the particular number divisible by 3? 6. Then the number is divisible by both 2 as well as 3. That means from here, if you look for 3, this particular term, this I can write it as 10c0, 10c0, 3 to the power 10 plus 10c, sorry, 10c0, 3 to the power 10, okay, minus 2 to the power, okay, or you can write this as, or better to write this particular number as, okay, not to solve like this particular fashion, or I can write this 3 as 2 plus 1 whole raised to the power 10 minus 2 to the power 10. This will become 10c 0 2 to the power 10 plus 10c1 2 to the power 9 plus 10c2 2 to the power 8, okay, and so on, okay, up to 10c2, sorry, 10c8, 10c8 2 to the power 2 plus 10c 9 2 to 2 plus 10c10 minus 2 to the power 10. Okay, so if you look at this particular, so if you look at this particular term, the 10c10 terms get cancelled with 10c10 term here. Okay, and if you look at the rest terms except the 10c8 and 10c9 2 into 2, so the terms, this particular, all the terms has 6 in common, the remaining terms have 6 in common. How? Because if you see the value of, so 2 to the power 9, okay, 2 to the power 9, or you can also check that 10c1 is 10 and 2 to the power 9, 2 to the power 9 will basically, so from here if you have to check for the divisibility, because we have cancelled out these terms, okay, so from here this is the last two terms are remaining, like if you see this is 4, this is sorry, this 10 into 9 by 2, that means 45. So 45 will again have 3 common and 2 in this common, so that means this is again divisible by 6. Okay, and similar fashion these particular numbers are all divisible by 6, so except this last number, that is 10 into 2, all the numbers are divisible by 6. That means the last term which is left out, that is can be written as 6 multiplied plus this will become equal to 20, and if you divide by 20, this 20 by 3, so the remainder will be equal to 2. So the remainder for this particular problem, when the number k is divided by 6 is equal to 2. Number k is divisible by 6 is equal to 2. Okay, so which is the right answer to this particular problem will be equal to option number B. I hope this particular problem is clear. So with this, let us move to the last problem. Okay. Oh, sorry, the second last problem. All right. So this particular problem is again a very interesting problem. If you know the formula of base changing formula of log, that is, if you know this particular formula, that is a raised to the power log of n base m. This can also be, by change of base, you can also write this as n into, but this particular base must be, okay, can also be written as n into log of a base m. Okay, this is a base changing formula of log. Okay, this is a base changing formula of log, but all the particular relation are satisfied for the for this particular establishment of this log function. That means I can write this 3 raised to the power log base 3 of 25 x to the power minus 1 7 whole to the power 1 by 2 plus 3, and this can also be written as, so if I take 3 on this upside, so if I take 3 and change the base, what I can find, so if I do change of base, the 3 will go up, and we know the value of log a base a is also equal to 1. So this will yield the result, this 25 x to the power minus 1 x minus 1 plus 7. And similarly, if you do so, this particular value will be equal to, 5 x to the power minus 1 plus 1 whole raised to the power minus of 1 by 8. Okay, so what is asked in the particular problem? It is asked in the particular problem that the value of x forms a 9 term. So if you have to look for the 9 term, the 9 term will be 10c8, and the first term is 25 x to the power minus 1 plus 7 whole raised to the power 1 by 2. Okay, because this was 1 by 2 over here. Okay, I forgot to mention this 1 by 2 over here. Okay, so this is whole to the power 1 by 2 whole square. Okay, and then whole square into 5 x to the power minus 1 plus 1, okay, whole to the power minus 1 by 8 into 8, and this will yield to the result as 10c2, and 10c2 value is 10 into 9 by 2, that is 45. So 45 into this value will be equal to 25 x to the power x minus 1 plus 7 divided by this will value will be equal to 5 x to the power minus x minus 1 plus 1. Okay, and this is the result, and it is said that this particular value is equal to 180, and this particular value is equal to 180. So if you solve this particular relation, that is 45 into 5 to the power x minus 1 whole square plus 7, okay, plus 7 divided by 5 to the power x minus 1 plus 1 is equal to 180. And if you cancel out by if you cancel by 3, this is equal to 60, and this is equal to 15, and this is cancel with 15, this is equal to 4. So from here, if I assume 5 to the power x minus 1 as t, where t is positive number, then this particular value will be equal to t square plus 7. T square plus 7 is equal to 4t plus 4. Okay, so from here you get a quadratic equation, that is t square t square minus 4t, okay, t square minus 4t plus 3 is equal to 0. From here the value will be t minus 1 into t minus 3 is equal to 0. So if you check this, the roots are t minus 1 and t minus 3. So from here the value of t is equal to 1 as well as equal to 3. So if you look, so if it is asking for the possible values of x, so the possible values of, that is 5 to the power x minus 1 is equal to 1. That means the value of x is equal to minus 1. Okay, and similarly, if you have to, sorry, plus 1. Oh, sorry, very sorry. There is 2 only, plus 2. Okay, this x is equal to 2, and if the value of t is equal to 3, that is 5 x to the power minus 1 equal to 3. Now this is not possible for integral values of x. This is not possible for x which is an integer. But if the x to the power minus 1, sorry, I'm doing what I'm doing. It's a big blunder from my side. Okay, this is x to the power 5 to the power x minus 1 is equal to 1. That means that x minus 1 is equal to 0. That means x is equal to minus 1. So the only possible values of x for which this particular result holds is basically equal to x is equal to minus 1. From this, option number B is the right answer. I hope this particular thing is clear. And let us move to the last problem in today's lecture of the important JEE Mains problem. So it is asking the problem that to find for the lowest integer which is greater than this particular integer. Okay, with this particular number, it will not be an integral number, but if you see this is a number, okay, as maybe an whole number, sorry, maybe an rational number. All right. So if you look for this, so let us assume x is equal to 10 to the power 100. So if let us assume that x is basically equal to 10 to the power 100. So the expansion which is asked is basically 1 plus 1 by x whole raised to the power x. Okay. So we know that whenever the integral or the power or the integrand factor or the binomial term is basically not an integral value, then we basically use the general binomial expansion formula. And by general binomial expansion formula, this is equal to 1 plus n into x, that is n into 1 by x, plus n into n minus 1, n into n minus 1 factorial. Okay, sorry, n into n minus 1 by 2 factorial, n into n minus 1 by 2 factorial, sorry, okay, by 2 factorial. Similarly this will be by 1 factorial. Okay, I'm writing the factorial notation as equal to this particular value. Okay, like this also you can express factorial as. Okay, the factorial can also be expressed as this. So you all know these things. All right. So from here, and then this will be value will be equal to 1 by x whole to the power whole square. Okay, and plus n into n minus 1 into n minus 2 divided by 3 factorial into 1 by x to the power 3, and so on. Okay, after lot of terms, lot many terms will be there. And from here if you solve this will be 1 plus, so the first term will be 1, and for the second term onwards, if you take x square common to cancel out with this, the value left out will be 1 minus 2 factorial. Okay, so if you look at this particular, so if you look at this particular, this will be x square minus x. Okay, and if you take x square minus x by 2 into 1 by x square, so if you take x square common, the term left out will be 1 minus 1 by x, 1 minus 1 by x by 1 by 2. Okay, so this will be 1 by 2 factorial into 1 minus 1 by x. And similarly this particular terms will be, sorry, this whole term will be 1 by 2 into 1 minus x. Okay, and similarly so forth, the remaining terms will be left out. And this particular terms is similar to, if you look at this particular terms, that is 1 by x, you would keep out at common, then the terms will be 2 plus 1 by 2 factorial plus 1 by 3 factorial, and so on. Okay, so there will be terms like this. And if you look what is the expansion of e to the power 1, the expansion of e to the power 1 is 1 plus 1 plus 1 by 2 factorial plus 1 by 3 factorial, and so on up to infinity. That means if you take e minus 2, this particular term resembles to e minus 2. Okay, so the number which is basically n is equal to 1 by 1 plus 10 raised to the power 100 whole raised to the power 10 to the power 100. This particular number is something as 2 plus some number which is e minus 2. Okay, some number which is basically e minus 2, which resembles like e minus 2, and we know the value of e is like 2.71 something, so minus 2 there is 0.1 something. So that means the number n will be a number which lies between 2 and 3, which lies between 2 and 3. So number n lies between 2 and 3. That means the least integer which is particular greater than this particular number will be equal to 3. The only least integer which is greater than this particular number is equal to 3. Least integer greater than n is equal to 3. That means the right answer to the particular problem is equal to option number A, that is 3. So the option number A is the right answer to this particular problem. Okay, so with this I have come to the end of this all important problems of JEE Mains question paper on the topic of binomial theorem. Okay, so I hope you have enjoyed this particular lecture very much, and if you have done so, then definitely subscribe to my channel and also leave a like on this particular video. I will be back again with these kinds of important previous year question on JEE Mains topic for the different important chapters of mathematics. Okay, based on your JEE Mains point of view. Okay, so these will all be coming up on this particular platform only. So stay tuned and subscribe to my channel if you haven't done it, and press the bell icon to never miss out any incoming updating contents. Okay, so any important updates which I will share regarding JEE Mains paper solving techniques and tricks or your examination points questions, stay tuned for that. Okay, so with that I'll take a leave from the today's important lecture, and thank you.